The singularity is bullshit. Why is that?
The history of AI still has lessons to teach us.
There's another project called Psych that attempted to store all of the knowledge that we have as a civilization into this kind of logical structure.
What I want is not moral AI, I think it's moral human beings.
What were once philosophical questions have now become experimental science.
One of the great ironies of mathematical history, that computers get invented as a byproduct.
The golden age, as you described it, 1956, 1974. Tell us about this first boom of AI.
AI actually didn't have a good reputation at all. AI was viewed as kind of homeopathic medicine. Neural networks were regarded as a dead field. Oh wow, well we're really at the cutting edge now. This is a big research question, is about
Oxford's Michael Wooldridge is a veteran AI researcher and a pioneer. Oxford's Michael Wooldridge is a veteran AI researcher and a pioneer of agent-based AI. In this interview, Wooldridge is going to take us through the entire 100-year history of AI development, from Turing all the way to contemporary LLMs. Now you might wonder, why should we bother studying the history of a technology, right? Technology should be about the state-of-the-art techniques. It should be about the latest developments. What's the point of revisiting the old and outdated? It turns out there's at least two important reasons to study this history, and the first is that it'll help you better anticipate its future. Wooldridge is extremely skeptical that this iteration of AI will lead to the singularity, partially because he's lived through so many similar cycles of AI hype. Whenever there's a breakthrough, you always get apocalyptic predictions pushed by religious zealots, which sets up unreasonable expectations that eventually sets the field back. Studying this history of boom and bust will help you see through the hype and grasp at where the technology is really going. Now, the second and even more valuable reason to study this history is that it contains overlooked techniques that could inspire innovations today. Now, even for me, someone who started coding when I was 15, who studied CS in college and then went to build a tech company, Wooldridge uncovered entire paradigms of AI that I haven't even heard of. Wooldridge's claim is that these paths not taken in AI, right, the alleged failures weren't wrong, they were just too early. And so this 100-year history is a treasure trove of ideas that we should look back to today for inspiration. My name is Jonathan B. I'm a fellow at the Cosmos Institute, where we study the intersection of philosophy and AI. If you want to follow along this episode via transcript, the link is in the description. And without further ado, Michael Wooldridge.
This is the provocative chapter title in part of your book, The Road to Conscious Machines. The singularity is bullshit. Why is that?
There is this narrative out there, and it's a very popular narrative, and it's very compelling.
To critique the psychology here, but what do you think is wrong, or what do you think people miss about the argument itself? That once we have super intelligent, or at least on par with human level machine intelligence, that they can recursively improve upon themselves. What do you think people are missing when they give too much weight to that argument?
The frustrating part is the Skynet part of the argument, the kind of the Terminator thing, that suddenly this will spiral out of control in ways that we just can't control in an incredibly short period of time. If you look under the hood of how these things work and how many patches are required to hold AI together, it just doesn't seem terribly plausible. More concretely, there are basically two arguments for how existential risks might come around. And the first is the famous paperclip argument, which I'm sure you're familiar with. So you build a highly intelligent machine and you ask it to build as many paperclips as possible, and it follows your instructions in ways that you didn't anticipate.
Right. For example, enslaving all of humanity.
Enslaving all of humanity. We are heading into a world where basically within a decade, 2 decades, I think at the most, pretty much everything we read and see on social media and the internet is going to be AI generated. And we're not going to know what's real and what isn't real in that world. And there are many, many risks associated with that society just fragments because there is no common core of beliefs anymore, that we're all obsessed with some particular issue, and that social media and the internet is just driving us around that one particular issue because AI is programmed to pick up on the issues that you care about and to feed you stories emphasizing those risks and so on. Where I was particularly concerned is going into elections in the US, the UK, I was really worried that what we were going to see was social media drowning in AI-generated fake news.
Right.
We didn't see that, as it happens, at least not on the scale that I feared it might occur. But nevertheless, I wouldn't take my eye off that as a risk. I think that's a very, very real risk.
Right.
That
behind these like neural net laws, as you described, is kind of preemptive. Like, oh my God, like if we don't set up the right controls, like it's going to spiral out of control and then we're going to have Skynet.
Yeah.
Whereas you're saying because we should be more moderate in our expectations of what it can and cannot do, including the harm it can do, we can just regulate this like anything in any technology or any physical industry and infrastructure that we've had in the specific use cases. Right?
That's what I prefer to see.
Right. So far, we've talked about the forward-looking view. I want to spend the rest of the interview really diving into your book and talk about the historical view of AI. But let's begin with a question that I imagine many people in technical disciplines would have, which is, why should we care about the history of AI?
Because the history of AI still has lessons to teach us. And one of the big lessons that it teaches us is that it's very easy to get overexcited and to read too much into what you're seeing in AI. And people have done that on multiple. So many cases, it turns out that the answer it's giving us is an incredibly useful one, even though we sacrifice something, and what we sacrifice is kind of guarantees of correctness and optimality. But nevertheless, it just turns into such a powerful tool. So the paradigm shift is towards a kind of data-driven world.
Totally. And so I did my computer science degree 2016 to 2020. And if you had asked me the history of AI, I would have given exactly what you told me and no more. But reading your book, it extends another at least half century, right? And in fact, there's a whole other dimension of AI about explicit programming, what you call symbolic AI. That's been completely overlooked. That was the dominant paradigm over ML. But now when we think AI, we think ML. And so there are perhaps intuitions that we can rescue in the next hour for even the leading technical researchers. But let's go to the very beginning.
So the Turing test goes as follows. Roughly speaking, you have a human judge who's interacting with something via, as he described it, a teletype. But imagine a computer screen where you're just typing, typing whatever you want. They could be questions, but they could just be whatever you want. And you're getting responses through that screen. And you don't know whether the thing on the other end that's producing those responses is a human being or a computer program. And the Turing test says, if you cannot reliably tell the difference, that is, if this machine can effectively pass itself off as a human being, then stop arguing about it. There's no point in arguing about it because you cannot distinguish between what the machine is doing and what a human does by any reasonable test.
So there's two ways to interpret the Turing test philosophically. One way is to reduce metaphysics to phenomenology. And this is to say, look, the metaphysical question of does it understand something? Is it really thinking?
Same way that a human being or animal does. The weak version of AI is, no, they don't really understand, but they can simulate those things. I'm not terribly interested in strong AI, except after a couple of glasses of wine in a chat with colleagues. And I don't know very many AI researchers that really are interested in strong AI. The goals of AI are much more pragmatic. By the way, I think for all practical intents and purposes, we passed the Turing test at some point in the last few years.
Of course.
But what that illustrates is, I think, is just actually the limited value the Turing test has as a real test for intelligence.
Right. For me, the only reason the consciousness of a computing machine has or does not have, the only real concern for me is whether we have to treat them as moral agents, right? If you think that a machine might be suffering and doesn't want you to turn it off, we might have to give some weight to that. But that seems to be like the only possible reason.
A beautiful idea which beguiled an enormous number of AI researchers. So the idea of logic programming takes symbolic AI and knowledge-based AI one step further. And it says that, okay, if we want to build machines that have knowledge, the way that we give them that knowledge is by expressing that in the form of logic, we give them these logical descriptions of the world.
This is Aristotle, essentially, right? If Socrates is a man, all men are mortal, Socrates is mortal. This is Aristotelian logic 101.
Exactly so. And we give it all of the knowledge about a particular problem, whether it's diagnosing blood diseases or solving planning problems and so on. We express that in a logical form, and then inbuilt logical reasoners will sort out the details for us. They will do the logical reasoning. And so the idea there was in logic-based AI that intelligence is primarily a problem of deduction, of logical reasoning. And it's a beautiful and elegant idea. And the war plan program, you say, with 15 lines of code, it's a ridiculously short program.
So make a lot of this early internet stuff obsolete?
I think it is inevitable one way or another. I don't know. I think absolutely the history of computing tells us that this surely must, all the lessons that we learn from the history of computing point to the future of AI being not just one big isolated system, but multiple AI systems interacting with one another. Because that's how computing, the history of computing has gone. So I absolutely believe that. The problem is, I don't know exactly what that's going to look like. And that's what I'm trying to figure out now. That's what my current research is trying to figure out.
There's another way in which multi-agent systems, I imagine, are currently being deployed, even in LLMs. Not multiple LLMs talking to each other, but how you split work within one LLM, right? So the rough intuition is, maybe it's better to train actually 3 hidden LLMs. One's good with math, one's good with intuition, one's good with creativity or language. And then you have a job sort of processing unit that gives the different LLMs different tasks. Confident
they've really fundamentally never seen before. But this is a really exciting area of science. It's one of the key areas, I think one of the most important areas of science right now. And it goes back to this thing that AI has just become this experimental science in the way that it wasn't previously. And this is part of that picture, trying to map out these capabilities. And it's also really frustrating because these models, frankly, behave in slightly weird ways. You think you've got some principle or some rule one day, and then you just change your prompt slightly in ways that seem innocuous to you, and you get a completely different answer the next day. And it's, okay, so what went on there? Why did it change? But mapping that out is genuinely very fascinating at the moment.
Right. So I want to move on to the last part of our conversation, which is, I focused most of our time talking about the history on the symbolic AI side, because that I feel like it's almost a forgotten history at this point. Because when we think AI, we think ML and not the symbolic explicit.
A guy called Rich Sutton called The Bitter Lesson. And Rich is a very renowned machine learning researcher. And he said, look, the truth is we've made progress primarily in AI by some core ideas, but actually the big steps in progress we've seen are when we've been willing to throw 10 times more compute, 10 times more data. And so that is a sobering lesson, but there is still magic there in AI. I mean, so the fact now that we have machines like ChatGPT that we can have a conversation with, that we can turn the conversation to anything that we might care to imagine, compared to where we were 5 years ago, that is simply astonishing. Right. And, if I wish I was a PhD student now and having the opportunity to explore this kind of weird new landscape of AI and to try to figure out, what are the fundamental laws that govern these systems? What are the principles? Try to uncover the science underneath this technology. There is still so
much more success than something explicit like psych also tells us perhaps a sobering lesson about how our own intelligence works. And that to me, again, coming from a philosophical perspective, is the most exciting stuff about all of this, which I'll go back to, which is that what were once philosophical questions have now become experimental science. All right. Well, thank you, Professor. Thank you for a fascinating interview.
Thanks for watching my interview. If you like this conversation, I think you'd also enjoy my discussion with Nick Bostrom on his new book, Deep Utopia. It tries to imagine what there is left for humans to do after AI has surpassed us in all domains. Now, these interviews are a part of an AI series that I'm producing as a fellow of the Cosmos Institute, a nonprofit studying philosophy and artificial intelligence. You can find links to our website, the Bostrom interview, and everything else we cover today in the description below. Thank you.